Good morning, everyone. Let us continue with two-dimensional state of stress. In the previous classes, we have seen how a stress can be represented by its 9 components, that is the stress tensor, and how strain can be represented by its 9 components, that is the strain tensor. So, we are going to talk with respect to the two-dimensional state of stress. Let us consider a two-dimensional state of stress where sigma x and sigma y are the normal stresses. I will be considering only two coordinate axes, that is x and y, where their respective normal stresses are sigma x and sigma y. The next are the shear stress on the plane, that is tau xy and then tau yx. These are the shear stress. Okay, let us put it into a coordinate axis diagram. This is x-axis. This is going to be the y-axis. Let us consider this to be the body. Let us consider a point P on this body. Now, for this plane, the normal stress is sigma y. Similarly, the bottom, it's going to be in the negative direction, sigma y. And then here we have sigma x. Similarly, a negative sigma x. Yes, so at the corners, we will be drawing the shear stress. It will be pulling it into the respective direction. So this is tau x y and this is going to be tau y x. So here also in these planes it will be acting in this particular direction. Here it is tau xy in the positive, so here obviously tau xy in the negative. Here it is tau yx in the positive, and here it is tau yx in the negative. That is, it pulls the body like this in the corners. Okay, a perfect body, which was a rectangle, gets pulled into a somewhat deformed body. So here we have the shear stresses that are going to be generated. So the stress components for this can be represented in the form of a matrix as the stress components can be represented as a 2 by 2 matrix. We have only two planes, two types of stresses, two types of coordinate axes. So total 4 components. In the previous class we had 3 components and then 3 types of coordinate axes. Along the principal diagonal elements we have a constant sigma x and sigma y, that is the normal stresses, and then your shear stress fills up the other places. So tau xy, tau yx. This is the two-dimensional state of